Hello, everyone. Welcome to the EasyPower Tuesday Refresher webinar series. My name is Jim Chastain. I'm Solutions Engineering with Bentley and EasyPower expert, quote unquote. And today we're going to be talking about a clever module and EasyPower offerings that are included with the 2024 update and most all the different bundles of EasyPower offering. So welcome to all. And as we're in the habit of doing, I'd like to start with a quick poll question. For those of you that haven't attended a webinar before, we provide a certificate of attendance to everyone that attends, and many people use that to support their extended education credits. And we will be recording the session and posting on the website, and you will receive via email a link to that posted website of the video. So as we are in the habit of doing, I'd like to start with the poll questions. Appreciate your participation. First poll question is, how do you currently size system elements in a new design? Again, no obligation or liability. And I'm just trying to get some feedback on where you currently stand with this particular task. For those of you that have not attended a ArcFlash workshop, we do a monthly ArcFlash workshop where we do provide the tools, the same tools that I use for the demonstrations and the workshop, to all people that register for the workshop, and they give you a chance to play with the AutoDesign for 2 weeks. So just a heads up. So it looks like we're close to a quorum. Let's leave this open another 10 seconds. All right. Here's how people have weighed in. So it looks like we have a majority of people using the datasheet lookup method, which is, for those of you that have other methodologies, feel free to make a note on the chat window, just for my edification, nothing obligating you for sharing anything. Okay, the next question is, how often do you predict short circuit, or do you have to predict short circuit and ArcFlash results before knowing which component supplier will be used? This one's a little bit more dicey. And it's something that seems to come up a lot. For design systems when you don't know where the low bidder will be on the construction side of things. So again, no obligation or liability. We're close to a quorum. All right, thank you for participating. Interesting, so we got a 50-50 split between rarely and often. I don't know what I expected, but that's a little surprising to me. Thank you for participating. Okay, so now the point is, we're going to be talking about the EasyPower AutoDesign module, what it does, how it does it, and what the controls do. And by this, I mean, we act like it's a plug and play situation, and in some respects it is, but the fact is, it has a particular formula, if you will, that it uses, and that formula for design decisions can be modified by the user. So the point is it doing what you want it to do, and how do you make that happen? So we'll be doing that as we go through this next 30 minutes. So what it does do is provide automatic sizing for low voltage equipment, and it's based on the loads, and it follows the recommended practices of NEC and IEEE recommendations. It can size cables, circuit breakers, fuses, transformers, specifically medium voltage to low voltage or low voltage to low voltage transformers. So it's not a catch-all. And we'll get into more of that as we go through this. So now for those of you that have EasyPower, if you've got access to EasyPower for the webinar that we do, the workshop, you can follow this demo, but my system must have an energy source, and I must have the load sized to be able to work the calculations. And so what we're going to see is I can size elements for a single motor control center load. I can size cables individually or in mass, and there are elements, or there are ways to lock auto sizing so I don't affect. I can make sure that nothing, if I've selected a particular size or part number, the auto sizing will not affect it because of that control. So let's jump into the example and see what it looks like. Now, for those of you that have EasyPower, the center column has the user's guide. This will bring up a PDF copy of the user's guide for the whole tool suite, and the details of doing smart design is dedicated to a chapter in this book. So I invite you to take a look at that if you have access to it. Meanwhile, I'm going to open the sample folder. In my case, my tools are installed into My Documents, EasyPower 24.01 lines. And under this folder, there's a sample folder. And inside of the sample folder is a smart design example. So I'm going to open it up. Okay, for starters, I need to have an energy source. So if you don't have at least a utility or a generator or a battery in your system, our smart design will not be able to do anything. Secondarily, it only controls or only will size medium, low voltage equipment. So if I have a medium voltage element, for instance, this fuse or this cable, it will not be able to size those. So the procedure goes something like this. I'm going to left click and drag to select my system. I'm going to go down to Auto Design. I'm going to invoke Auto Design. As I do that, the tool comes back with some values for the breakers, the cables, the transformers, and if we look at the system elements, even the loads. Now you might say, well, where did this stuff come from? For instance, this first cable is a 1C 350 kcmil with 99 feet long. Where did that come from? Well, it came from the database that we've pre-selected in the rules, and so I'll be jumping into that shortly. But the point I want to make is I can size this individual copy. So I'm in database edit. I'm going to go out and open up the dialog box for this cable and intentionally missize it. So let's say this is, for some reason or another, I have this set up for a 14 kcmil or size 14 AWG and a single conductor per phase. And so I'm going to go ahead and auto calculate. So this gives me something, whether it's right or not, I don't know. My point is I can go in and resize an individual cable by right-clicking and auto-design that element. And as I do, it comes back with the two conductors 600 kcmil. Now the difference is, or the 99 feet comes from one of the rules. And if I have the size set up for a different length, let's say 75 feet, now when I invoke auto design for the cable, it will utilize the 75 feet in the calculation. Okay, and then likewise is true with the motor control center loads. If I'm in database edit, I go into description, I can size each one of these individually. For instance, here's a motor. I can right click on the line element, auto size protective device and cable. And as I slide over, you can see it's got a generic multi-case circuit breaker standard MCP 150, and the conductor's been sized for a number 4, 99 foot long. Okay, so this gives me a clue as to where things are, what is going on, and the rules control that decision. If I go to auto design options, I can access the rules that are being used. So first of all, it's going to use a library sheet from the device library, and the choices include 2 generic data sheets, and we'll get in and look at these in a second, and then 2 each from 4 different manufacturers. So there's Cutler Hammer, GE, Siemens, and Square D. So this first time through, I used the generic database. I'm going to use Square D this time around. We're going to create it. We're not going to worry about bill of materials. We're going to use the code to do the sizing for downstream loads, although we can choose one of these other selections as an alternative. We can size part of the system or everything, so let's size everything. If I have any motors in the system, I have the ability to select the motor description. So we're going to use full voltage non-reversing for now. When it comes to cables, if there's not a length of cable, the cable length indicated, we're going to use 99 feet to calculate the voltage drop. And that way, whenever I go back and do a search on 99, I can update the lengths of the cables as my design requires. Likewise, protective devices. I can choose a maximum available, pickup, or minimum available selection. And then the feeder breakers are based upon the bus rating or the load for that particular bus. And then based upon the lock rotor multipliers that can be changed, I can calculate the downstream voltage drop based upon exceeding a 5% drop. I can upsize the conductors, in this case by 20%. I can change these variables as well. So right now, I'm going to go in and look at analyzing this system with a Square D device library and see what happens. Now, one point to be made is I indicated it's not going to do anything with this medium voltage cable, so I need to go in and fix that or address that as far as the size. And let's say it's 55 feet long. It's an XLP. We're going to auto calculate. And it's rated for 395 amps through a steel conduit. Okay, so first pass was with generic. This pass is going to be with, I think, Square D. Invoke AutoDesign. It's going to think about it for a second. When the color comes back to me, now I've got all Square T part numbers. And they're sized for the downstream load. We've got transformer sizing based upon the load that's been connected. And if we go in and look at the schedule for the motor control centers, we can send, this was already set up for main lug only, so it didn't size anything there. But for my static loads, these are the static load values. And I'm showing the Square D part number and the trip and the interrupt rating, and then the conductors, again, all with 99 feet. Now, again, if I didn't want to, if I have these all manually set up and I don't want to change it, I can go in and lock auto sizing so it won't be affected by the next time I run the program. Okay. Any questions about that? So now I want to go in and find out where all this is being controlled or how I deal with that. Now, one of the more helpful features of this module is the ability to generate a report giving me the justification for each decision that was made. And if I go to my list of windows, I'll see on my report generation an auto design report, and it shows me that the fuse wasn't sized, the bus and the high voltage wasn't sized, nor was the cable, which we expected. Here's the transformer selection and the justification for the transformer sizing. And then the rest of the elements in turn. Now, not all this is going to be perfect. And so where it throws an error, it gives me a warning that there was 1500 amps rated, and we're tapping it equal to the sizing on the amps. So a human may want to check this out. So again, there's justification for each decision that's been made, and where there's an error shown, this is where a human needs to interact. For instance, in this panel, row 11, it wasn't sized because the bus ampere rating for the circuit and the calculated downstream amps were both equal to 0. And so it stuck with the sized cable that we had initially set up. Okay. Now, so how do we control all this? So first of all, what we've done so far is we've done everything with the basic default rules. So the question is, how does this affect my example or my decision process? The types of circuits that the module is set up to recognize are motor circuits, where we have a direct motor to a bus and a protective device, or a cable or two cables. Feeder circuits, where we have downstream panels or discrete elements. And MCCs with the ability to have downstream elements. And then transformer circuits. Again, the loads are discrete or separated, and the tool can calculate the loading from each feeder. Okay, I keep referring to the design library and the database device library. So that's where we're going to look at it now. If I come up to File, Open Device Library, let's look at my standard. Now just for grins, you'll notice that I have other values or other device libraries available, and these are modified to support that particular operation or example that I want to run with that setup as far as the library itself. So there could be a need to have different libraries based upon my selection used for part selection. So let's go ahead and open the standard library. Now we keep talking about the devices selected and the devices available, and the data sheets for all those devices are listed up here at the top under this top section of the device library. So cable calculations, multi-case circuit breakers, fuses, switches are all detailed, and if there's a manufacturer making a part, this is where you would find it. Now, as far as auto design, it refers to this little module down here at the bottom, and in that, I mentioned we have several catalogs, 2 each from 4 different manufacturers. So here's the Cutler Hammer, GE, Siemens, and Square D. Now these are different from the listed of the parts up above because these refer to decision trees that I've created or that have been created. These are included in your default installation that were included based upon using this catalog for part selection. And how that is done is that there's a list of motors. Again, there's a list of feeders. Again, protective devices for single phase, 2-phase, and 3-phase. Now this is where the decision tree can be modified by the user. So currently, under this selection for Cutler Hammer, when we have a switchgear designated as the equipment, and these current ratings or current demand are put on the system, I can have a transformer load that's determined, or protection that's determined by these selections. So I take that back. These are all GE parts, and GE 2007 right there. So if we have this load on a switchgear, this would be the first choice, and these would be the designations of the solid state trip unit. The point being, these will change based upon how I've designated that particular bus. So I can call a bus panel board or motor control center, and it will change the designation or the return that the auto design will provide. Now these are sections. If you go ahead and look at the generic, we can look at the protective device selection. And in this case, we're using generic manufacturing names, but these are a different selection that have been constructed for a particular project. And so if I want to use, if I don't want to have a manufacturer, if I wanted to use the vanilla part number, I could use the generic and then make adjustments to it if my project had parts that's not on this list. For instance, if we look at transformers, if we have a 600 volt transformer, say 12.8 to 600 volts, I don't have one listed. And so that would be an error that would be reflected once I run AutoDesign. But once I put that transformer in this library or in this selection sheet, it would then be available for selection by AutoDesign. So the point is you can customize the decision tree, which is based upon the loads, the conductors, the protective devices, the type of equipment that we're using, and the transformers. You can control how the selection is made, both in manufacturer, because I can use any manufacturer, or generic selection. So for instance, if I wanted to add the new primary voltage, let's say was 12.8 and secondary voltage was 600, it would give me that capability, and then I'd have the ability to do kVA entry for whatever the transformer designation is in this particular range. And it would be available then next time I had a choice or a circuit that had this transformer requirement. Okay, so it feels like I'm kind of stumbling around, but my point is it's not a plug and play tool as it is first launched, but it can become a very clever way to do auto sizing for your particular needs if you understand where the adjustments can be made. So first of all, you can adjust the rules. So if I go back and close my device library, I can adjust the AutoDesign rules under options, pick out the catalog I want to use for part selection, decide how we're going to be doing the downstream load comparisons, the motor starters, whether or not I have values for the length of the cable or not. I could go in and put in 55 feet as the thing I want to use for typical values. So adjusting the rules for selection, and then adjusting the database to reflect the part numbers that I want to use in the project, make it a very versatile tool. So I'm going to try this one more time. I'm going to go to AutoDesign, Options. Let's use GE 2011. Now, one of the questions is, how current is the pricing? And the answer is, it's not current. It was good at the time. And so approach the costs involved with the jaundice eye. You can change the pricing on the catalog to reflect what you know to be the current price, and consequently your installation would be more valuable to you than it would be to me. And once I select everything, invoke AutoDesign, look at my one line, and it will reflect the rules that I put in place. And then under my list of windows, I look at the justification for the decisions that were made. Any questions? So basically, the AutoDesign can size low voltage system elements that use a prescribed list of components that I can control or that can be modified, and then controls of the decision tree will guide the selection as needed. It's an interesting tool to try out, and by all means, if you have other questions, feel free to contact tech support or me, and we'll talk to you down the road.